what you are getting from the averagement. So, those who are sitting for A-level science stream, we have a physics, chemistry, bio. Some people take maths instead of bio for the physical science. Instead of chemistry, most I have seen some are taking IT or some other relevant subject instead of chemistry. I hope there are some students in this category too. Here, in these three subjects, physics is the one we are discussing about. In this physics subject, why we need to get more score? What is the important? What is why? What is the importance of the physics? How we can score marks? You know, learning is a skill. Okay, learning is a skill. A teacher can teach you. A lecturer can make a syllabus delivery to you, but he can't give you your marks. You have to learn. So the thing is how to learn. That is a very important subject. How to learn. Because study or learning is a skill. You have to understand or you have to develop how to learn rather than learning various things. So people, okay, let's say, even if you take a one subject, some people go for X, Y, Z, 3 classes. Some people prefer P, Q, R, 3 notes. For the same thing. For the same thing. So here they are going and learning about the units and dimension. Here also they are learning again units and dimension. Here units and dimension. Come and reading different book units and dimension. Finally, are they trying? Are they in any question? Will you able to explain? Will you able to explain? If you can't explain, that means you didn't understand. So you have to learn such a way. You have to explain it. You have to clearly explain to your friend the way how he can understand. It is very important. Therefore, going for the different classes or referring to different notes are not a particular or not a successful way of getting good results. Good results depends on how you learn, how you approach, how you develop your confidence on questions. That is very important part you have to develop in these 2 years of time. For an example, I normally say, if Newton comes and teach you physics, now let's say Newton is the father of the physics. If Newton comes and teach you physics, it is not sure, he can't promise that you can get an A in your exam. That depends on you. You can sit at your home and read your syllabus and teacher's guide. If you can able to manage it, yes, you can get A. So it's mainly not depends on the teacher how you are learning. That is very important. So in the first class, I am explaining you that learning or getting a results not depends on your teacher. It totally depends on you to learn. A teacher who can guide, a teacher or a lecturer who can guide you how you want to learn, not to feed, not to make a of subject that will not work in advanced level. Keep in your mind the O-level learning, how you have learned in your O-level, how the paper you focused will not work in advanced level. That is totally spoon feeding. This is totally integration. You have to integrate. So for an example, I ask you, I will start my thinking by a small question. Let's say a car. You may have learned in your O-level in a Newton's law. 3 theorem you may have learned in your Newton's law. O-level physics in Newton's law. You may have learned. If I say simply, if there is no force, no movement, it will be behind rest or move with a constant velocity. If there is a force, it will accelerate. Everyone knows this one. Every action has equal and opposite reaction. Yes. My question is, you have a car. If you stand back of the car and push the car, what will happen? Car will move. Car will move with the acceleration. Yes, that's fine. I take another question. I change this one. Let's say man is not outside. You are sitting inside the car and pushing the car. You are sitting inside the car and pushing the car. Will the car move? Will the car move? This is one general knowledge question I started with you. Will the car move? You can answer it even. Will the car move? Yes or no? My question is, if you have a car, once you push the car from inside, will the car move or not? Okay, most of you answered no. Why? The reason? What is the reason? What is the reason? Why? What you understood on the why it is not moving? Any solution? It is not an external force. Resultant force will be 0. Okay. We have no external force applied because force is acting downward by our body. Okay, we'll think about it. Now you see, so your answer, whether it move or not, your answer is, okay, no, that is correct, actually it's correct. Then the explanation for that. Now the thing is, when you have an object, if you apply a force externally, so the Newton law said, the first equation, first law of Newton said, if there is no any net external force, look at this, no any net external force. So not internal force, no any net, that is very important, net external, okay. So total external force is 0, okay. Total external force is 0. Summation, this is, you may have known from your level summation. Total external force is 0. If it's so, Object at rest, remain at rest. Object with a constant velocity, maintain the velocity. If you have someone, he is staying rest. If you are not disturbing, if you are not giving any external force, he will be remain as it is. He will be remain as it is. If someone is moving, if you are not disturbing him, he will move on his way. That is okay. The second statement say, okay, if there is a when a net external force applied, look at this, external force applied. How nicely he represented. Earlier he said no external force. Now when you apply a next external force, summation of F is not equal to 0 now. Apply it, accelerate, but in the term the change will be a rate of change in momentum that we can learn later, but it will accelerate immediately. So if there is a net force, net external force applied, yes, it accelerates. The third one, we know that every action has equal and opposite reaction. Now, look at the scene. If I give a force to this building, okay, this is the wall, I give the force. But nothing happens. Why? We are inside this building. This is not the external force, it's the internal force. So, the car, when the car is there, if you pull from the car, yes, you are pulling or you are pushing inside the car, you apply the force to the car, force on car, but you are getting a force by car. Because every action has an equal and opposite reaction. If you apply a force on the car will give you a force by car on you. Every action has equal and opposite. So for the system of this car, you see, this force is equal to this force. There is no net force. It won't move. But the case when you are outside of the trolley or the car, yes, you apply a force to car. Yes, force on car. It will give a force to you, force on man by car, but you are on a floor. So that is not an internal force, that is externally, that is a separate body. This is having a separate body. You are getting a force, so you will accelerate. That's how it clearly says, if there is no any external force, object at rest remains at rest. If there is no any external force, object at rest remains at rest. Object that is moving with a constant velocity, it will move continually. It will move or it will maintain the constant velocity throughout. It will maintain the constant velocity throughout. Okay. So do we have any doubt? What is net external force? Good. Now the question is, what is net external force? For an example, let's say you have a box. One person is pulling this one with 100 Newton of force. Another person pulled this one with 20 Newton of force. Now look look at this. We have external force in two directions. You have to find the equivalent force, which is, okay, we can say, either it is subjected to two external force, as a resultant, it has a force in this direction, 80 Newton. So this is the net force. This is the net force. Is your doubt is clear? Do you have more? Case of motorbike, and we apply force while sitting on it, whether it's internal or external. So, in the case of motorbike, and we apply force while sitting on it, whether it's internal or external. Look at this. If you are sitting on a motorbike, let's say, if you are sitting on a motorbike, if you are not contacting the ground, by your leg, still it is an internal force because you are on the motorbike and trying to push the motorbike. Yeah. So there is a force on bike, there is a force on you, then there is no net force. But if you hold your legs, down to the ground, and if you push externally, if you push the ground, yes, then that is the external force. Because there is a two frames are concerned. Okay, good. Further. Is there any more? Sir, is the resultant force the net external force? Look at this. Now, this is 20 Newton, this is 100 Newton, this 80 Newton is net external force in this case. Okay. Now we will take another scenario. Let's say an object which is subjected to this side 60 Newton, this side 80 Newton, this side 30 Newton, this side 40 Newton. Okay. So there are four different external forces are acting in four directions. So if you consider this, you can say, yeah, horizontally we have 60 Newton and 30 Newton. So net force will be 30 Newton. Vertically we have 80 Newton, 40 Newton. So downward we have 40. Now you have two forces, but two forces are perpendicular to each other. There are two external forces, but both external forces are perpendicular to each other. If someone pull me this side, if another one pull me this side, I will move either of this side with the balance force. If someone pull me this side, if another one pull me this side, how I want to move? Let's say you have a football, okay? One player is kicking on this direction, at the same time another player kicking on this direction. How the football need to move? You need to find a resultant direction. So if there are two external forces acting in two different directions, we need to find the resultant net force. We have to find the resultant net force. So if it is 90 degree, we can use Pythagoras to find the resultant net force. Hope it's clear. Okay. Good. Is any more? Any more? Okay, we'll see further. Now, let's think. As I said, if there is no any external force, object at rest, remain at rest. For an example, let's say you have a trolley on a frictionless surface. You give a force from upward as a F force. Now, it is external force, externally. You apply from upward. You are pushing like this. So, for, let's say I am here, someone is pushing on my head like this. So, what will happen? Is it able to move? Or will it able to change the motion? So, when we think about it, this force is getting in vertical direction. So, in this direction, we have to consider, because force is a vector. It has a both direction and magnitude. Remember, all the thing what I am explaining, but you have learned in the O level. I am not coming to the A level things. Direction and magnitude. So you have to consider the direction and you have to consider the motion in that particular direction. If there is a force applied on this direction, you can think about the motion in this direction. This side motion is restrained. What is restrained? Limited or blocked or restricted. Therefore, it won't move in this direction. In this direction, is any net force? No, any net force. So, no movement. Look at this. Here, in vertical direction, even if you push this one, the motion is restrained because there is a road, it blocked the motion. But this force is vertical, not horizontal. Therefore, the vertical forces will not induce any movement in horizontal direction. Hope that will be clear. Now, so I just wanted to make you sense of theories. So while you are learning, you should understand the fundamentals. For an example, I will touch a small thing which you have learned in your oral. Okay. Let's say you place a box on a table. It's a table box. Can you mark the force? Mark all forces. here. First of all, if you take this box, it has a mass. When there is a mass, it will be attracted by the earth. This is mg. I can say, if you want to name it, weight of box. Otherwise, I want to say force on mass by earth. Force on mass by earth. Now my question is, okay, every action has an equal and opposite reaction. Where is the opposite reaction of this mg? Where is the opposite reaction of the mg? So who gives the force? Force on mass by earth. Who gave the force? Earth. So opposite reaction should be on earth. So if you have an earth, if you place a mass here, yes, if it is attracted by the earth, there will be a force on the center of the earth by that mass. So this mg is again mass, force on earth by mass. Understand? Look at this carefully. Every action has equal and opposite reaction. So if you have a weight, yeah, that is weight of the box mg. The real meaning of the weight is force on mass attracted by the earth. So the real reaction of that should be who attracted? Earth attracted. That should be on the earth. So if you draw the earth on the earth's center, there will be a force on earth by the mass. So that is the action reaction couple. Okay, that is okay. The next one. When you keep this one on this table, once it touches, we feel the content. Okay, content. So if I remove this hand, it will fall. So you are restraining. If you remove this one, it will fall. So by having a hand here, or by having a table here, you are not allowing this one to fall. If you are not allowing this one to fall down, move down, there is a restraint. This is the restraint block. If you restrain it, there will be a reaction. R on box by table. R on box by table. Now we have to think. Every action has an equal and opposite reaction. So R on box by table. Who gave the force? Table gave the force. So reaction should be on table. So on table there is a R. Okay. Action on table by mass, by box. Action on table by box. Look at this, how we are marking the action reaction point. You can post if you have any doubt regarding the concepts. So if I don't know, I don't know why you have mentioned the volume is too low. Even if it is a volume is too low, for this one, that's why I have drawn a small mass, but it has a considerable weight. Okay, but this force will be okay. I will explain it again. I will explain it again. Look at this. if you have a mass on a table, it has a mass, it's a table, box on a table. What are the forces will be there? One is, we know, mg, the weight. So mg mean, we can say force on box by earth. By earth. Every action has an equal and opposite reaction. So the reaction, the opposite reaction of this mg will be on the earth. You take the earth, there is a mass, it attracted by the earth, so earth will be attracted by the mass. So the Newton couples are these two. Okay. When you keep the box on a table, it is a content. So we are making a restraint, otherwise it will fall. Therefore, there is a reaction on the mass or on box by table while in content. So here also every action has an equal and opposite reaction. Action of this R will be on table. Who gave the force? Table gave the force. So there is a force on table or on table by box. So if you separate these, on box there are only two forces. One is mg, other one is R. On table there is a force R. This one and this one are the Newton's couple. Action, reaction couple, according to the Newton third law. Hope it will be clear. Okay, there are more. This is O level, not A level. I didn't touch anything in A level. Okay, what happened to the force cam on the earth? Yes, earth can get whatever the force it is. It can able to resist whatever the force it is. So earth will able to carry that force. You should understand it properly. The fundamentals. This is very simple example of where you keep the box on a table. But you have to develop. That is where the A-level learning is something different. So in O-level, you have learned something. A-level, what you are going to do, you have to develop this. What will happen if the objects and everything changes? Even if it is if you come to the engineering, even if you want to design about the Lotus Tower, fundamental is this equilibrium. We have to check the equilibrium. So you should understand basically, Newton's law have to be cleared properly, or the fundamental of Newton's law to be understood properly, to learn whatever the things, okay, whatever the concept you wanted to understand in any part or any chapters of this. Okay. Now I will make another example, which also there in your books in O levels, not in A level. Look at this. I just wanted to refresh your mind, and you have to get some idea what you are going to learn. Okay, you have a mass hang on a rope, which is connected to a ceiling. Okay, it's a rope, a mass. Okay, we have to mark the forces here. We have to mark the forces here. Okay, and there is no upthrust force there is no upthrust force, we are considering this is in a vacuum. If you have some air or amount of air or water, you have to consider upthrust force itself. Okay. Now look at this. Mass, no? So it should have an mg. Mg is the mass that is attracted by the earth. Newton couple will be on the earth. That's no problem. If you keep this one, if you hang this one like this, okay? If you hang like this, if you hang a weight like this, it will try to fall. It will try to fall. So if it try to fall down, I have to keep tightly. So this rope need to be kept tightly to avoid the falling of mass. So if you want to keep the rope tightly, there will be a tension T, look at T, on mass by rope. Carefully understand, it is acting on mass because the mass is going to fall down. The mass is going to fall down. To avoid the falling, there is a tension to be applied by the rope on the mass. So tension on mass by the rope. So who gave the mass tension? Rope gave the mass. So there will be a tension on rope. Every reaction has an equal and opposite reaction. This one. Tension again on rope by mass. Look at this. So if you give a force to the mass, there should be a force on rope. So if I draw the rope here, there is a T on rope by mass. Now look at the ceiling. Look at the ceiling. It is hanged like this. So ceiling is going to be pulled down. Ceiling is trying to pull down. So there is a force on ceiling. P dash on ceiling by rope. So I can put ceiling here by ceiling by the rope. On ceiling by the rope. On ceiling by rope. So there should be a couple that will be on the rope. P on dash on rope by ceiling. So look at this. This one and this one are Newton couples. This one and this one are Newton couples. So we know that the third law, every action has an equal and opposite reaction. That is true. But look at this. Those are equal in reaction, equal in magnitude, opposite in direction. Yeah, that's also true. Equal in magnitude, opposite in direction, but acting in two different bodies. Look at this. Acting in two different bodies. Acting in two different bodies. Hope you all understood this one. We'll clarify the doubts. Forces on the earth mean gravitational force, right? Yes, definitely it's a gravitational force, yes. Upthrust force I explained. The tension, that is the tension, okay? Here, the T, what I say is the tension. T, what I say is tension. Now look at this. We will take a small mass like this, another mass like this. Look at this. This is how we have to improve. Always you have to improve one by one by one from fundamentals. Look at this. This is the object A. This is the object B. Now I'm going to mark the forces. Okay. Mg of this one. So I can say MAG, mass of A by the earth. So A will be able to fall down. So you have to keep it by the rope. So T1 on mass A by rope T. So this is rope P. T1 on mass A by rope P. Okay. T1 on mass A by rope P. Then look at the next one. Every action has an equal and opposite reaction. So on rope, look at this T1. On rope P by mass A. Okay. So the B will get a weight of MBG. This is the mass of B. So this rope will pull this B. So I can mark T2 on mass B by rope P. So every action has an equal and opposite reaction. So this side T2 on rope P by mass B. Mass B will pull the rope upward. Okay, hope you understood. This is the things what we have discussed in the earlier example too. What is T1? The T1 means tension. Look at this. This T1 is tension. I mark tension. You know, when you think about the rope, it's tension, the tensile force. When you think about the rod, I will take a rod. Look at this. When you think about the rod, compression. You compress. So if someone, okay, push me down, it's a compressive force. If someone pull me, that is a tension force. So we are pulling the wire. Then it will be the tension force. That is I mark as a T1. Okay. Like T2 also tension. Now look at this. Now B is going to fall down again. Then you have to keep the B restrained. So there is a force T3 on, let's say this is rope Q, on rope Q, sorry, on mass B by rope Q. So for the Newton couple, there is a tension on rope Q by mass B. Likewise, ceiling will be pulled down, let's say T4 on ceiling by rope Q. So there is a couple T4 on rope Q by mass by C. Look at this. Every action has equal and opposite reaction that will act on two different objects. So if you take the ceiling, look at this. Ceiling has only the one force T4. If you take the rope Q, you have T4 here, you have T3 here. If you have the mass B, you have MDG, T2, T3. If you have the rope T2, T1, if you have a mass M1, you have M1G and T1. Look at this. Please write it down and understand what is the fundamentals here. Okay, so you should understand the basics before you go to any deep theories. Is tension called negative pressure? No. The pressure is something different. Tension is something different, because tension is the force that is MLT minus 2. Pressure is force over area, force in a unit area, that is ML minus 1, T minus 2. So both are not the similar things. So we have to understand it separately. Pressure will be usable for the fluid. The force, the tension will be used for the solid. So pressure will come to the scenario when we are learning the fluid mechanics. Once we are learning the solid mechanics, tension, the forces will be we have to deal with the forces in the solid mechanics. Yeah. Okay. So now look at this further. Hope you understood. If you have anything to clarify, you can put in the chat box. So now we try to understand the way how the Newton's third law have to use in the applications. So when you think about the scalars, so it only consider the magnitude. For example, 20, 50 kilogram, 30 meters, 2 seconds. It only consider the magnitude. When you consider the vector, which is a little special, where we need to consider the magnitude plus direction. So the magnitude and the direction. For an example, let's say we have to mention, okay, direction, that means 2 meters in left side, 5 Newton vertically. So it has a direction. If you have scalars, when you add x plus y, you can find the z. Okay, it's a scalar, like 2 plus 3 is equal to 5. That's not a problem. But when it's come to the x vector plus y vector is equal to z vector, but if you take 2 vector plus 3 vector, you can't say it is 5 vector, because vector addition is not like the arithmetic addition what you follow for the scalars. So you need to how to mark the forces if two objects are placed horizontally to each other on a table. Yeah, I'll keep explaining it. So when you think about the addition of vectors, there are concerns. So you can't just add the vector only by adding the magnitude, like 3 Newton this way, 2 Newton this way, then resultant will be what? Yeah. The resultant of vector addition is mainly we can carry out by various methods. One is called arithmetic method, other one is geometric method. Other one is geometric method. Arithmetic method means numerical, geometric means graphical. So it's numerical, it's graphical. So if we have 2 Newton and 3 Newton, if there are 2 vectors are concerned, we can use vector parallelogram theory. So in this case, if 2 vectors are concerned, vector parallelogram theory can be used. If it is more vector, you have to use vector components. Graphically, you have to use vector polygons. Look at this. How easily, we have to make a learning tree to understand these things. So that is very important when you are learning the concept. Always you have to learn understandable in the easiest way, and you can trace it how we are going to apply. So what is the idea? Okay, vector parallelogram. If there are more forces, okay, what is the idea? We have to use vector component. Okay, so if someone asked about graphical, okay, we have to use vector polygon.